Today, we are going to learn how to find the solution of a system of equations by graphing. So we are going to start with a review of what are the possible outcomes. First, we're going to talk about one solution system. We say that this is a one solution system because these lines that we have right here are straight lines and they will always intersect once only, right here at this point. And this point right here is what we call the solution, the one point that both lines have in common. The other possible outcome that we have is a no solution system. We say that this is a no solution system because we have a system with parallel lines. So if the lines are parallel, they do not intersect. So if there's no intersection, there is no solution. The last and third outcome, it's infinite solutions. Now, we say that this is infinite solutions because the lines are the same. So this is like two lines, one on top of the other. They actually look like one. That's what we say, they are the same line. And we say that these lines always intersect. So if they are always intersecting, there's an enormous amount of intersections. There's an enormous amount of solutions that they will never end because, as we know, these lines keep going on each direction, so they keep intersecting. So there's an infinite amount of solutions. There's too many solutions, too many intersections to even be able to count. Okay, so now let's look at how our problems normally look like. Here we have an example. We have y equals 2x plus 1 and y equals x minus 1. So we have two different equations. So we are going to work for each equation. What we are going to do is going to be graphing here and see where do they intersect, so see what kind of solution do we have. In this case, both of my equations are in the form y equals mx plus b. Why is this so important? Because m is the slope of my line and b is the y-intercept. Knowing these two things is what I need so I can graph them. So we're going to start with equation number 1, or the first equation right here. This equation is y equals 2x plus 1. So in this case, my slope happens to be 2. So we say the slope of this line is 2. And the y-intercept is 1. So we say b equals 1. This is my first equation. So now we are going to graph it. So remember, the y-intercept b is normally what we call the beginning of a line. And the slope, which is the letter m, is normally what we say that it tells us how the line moves. So in this case, I'm going to start with my beginning. Here, for equation number 1, b is 1, which tells me that I'm going to start at the y-axis. I'm going to start at 1. Now, y1 is right here. That's the y value of 1. That's my beginning. And now, my slope is 2. So remember, this is a 2 over 1 because slope we know that is rise over run, which means that I'm supposed to move 2 up and 1 to the side. And that's how I find the second point. Now I can keep doing that. 2 up, 1 to the side, and that will be another point on my line. So after doing that, what we have to do is connect the points as best as we can using a straight line. And that is our first line. So we're going to do exactly the same with our second equation. Right here, y equals y minus 1. So our second equation is y equals x minus 1. So first of all, m is an invisible one right there. So we're going to say m equals 1. Then the y-intercept, b, is negative 1. So we're going to say b equals negative 1. So we're going to go again. Don't forget, b is the beginning. M tells you how to move. So we're going to start with the beginning, negative 1. Which means that we're going to go to the y value of negative 1. That's our beginning. From here, we're going to follow our slope. A slope is 1 over 1. Every whole number has a 1 on the bottom. Why do we want to know that? Because now I can do my rise over run. My rise is 1, meaning I move up 1 and then 1 to the right. So that tells me that my second point is right here. And I can keep doing it. 1 up, 1 to the right. I find another point, and so on and so on. Okay? So here we have enough points, and now we are going to connect these points that we have as best we can using a straight line. Okay. So just recap. The pink is my first equation. The green is my second equation. And I know, and I can see, that both of them cross right here at this point. This is the intersection. And that intersection happens to be my solution. In this case, is negative 2, comma, negative 3. Okay? We're going to do one more example. Here in our second example, we are going to continue using our equation y equals mx plus b. And one more time, we are going to say that m is our slope, which we say it tells us how the line moves, and b is our y-intercept, which normally tells us the beginning of our line. Okay, so let's start with our first equation. Y equals 2 over 3x minus 4. Okay, so here right away we can say that 2 over 3 is going to be our slope. So m equals 2 over 3. And we also can say that b is negative 4. So our beginning, b, equals negative 4. So we are going to start with the beginning. We are going to go to our line, our graph, and we're going to go for the y value of negative 4 right there. That will be our beginning, our first point for our line. Then after that, we're going to follow our slope, which is 2 over 3, meaning 2 for rise, 2 up, and 3 for the run, 3 to the right. That'll be the second point. And we can keep doing that. 2 up, 3 to the right. That'll be another point. So once that we have enough points, we connect them using a straight line to the best of our abilities. Okay. And now we move on to our second one. Our second graph is going to be 2x plus 3y equals negative 12. So number 2 is negative 2x plus 3y equals negative 12. And as we try to do this, right away we should notice that this equation, negative 2x plus 3y equals negative 12, does not fit the model y equals mx plus b. So what we're going to have to do is we're going to have to modify the equation to make it look like that. How? We're going to use our solving skills, meaning we need to leave the letter y alone. Isolate the letter y. And how are we going to do that? First, as always in solving, if I want to leave the letter y alone, I know I need to cancel the 3, I need to cancel the negative 2x. But the number that is next to my letter, in this case y, the one that I want to leave alone, is always going to be the last one we cancel. So we're going to start canceling negative 2x. How? With a positive 2x. And what I do to one side, I do to the other. What this is going to do is going to cancel the 2x's, because negative 2x plus 2x is 0. They cancel. And we're going to have 3y equals negative 12 and positive 2x. They're not like terms, so they stay separate. We're going to put x's first. 2x minus 12. Now we are ready to get rid of the 3. Now the 3 is multiplying the y. Therefore, to cancel, we need to divide. And here, pay attention, because both of the numbers, the 2 and the negative 12, need to be divided by 3. So we are going to have 2 over 3x minus 12 divided by 3, 4. So now we can see that our slope, it's 2 over 3, m equals 2 over 3. And b is going to be negative 4. So we can say b equals negative 4. So for our second line, we are going to start at negative 4. So I go to y, negative 4, and I mark my point. Then after that, what do I notice? Oh, my slope. I need to move 2 up, 3 to the right. So 2 up, 3 to the right, and look where I end up. In this point. And I can keep doing it. 2 up, 3 to the right, and look what I end up in this point. So as I connect those points, there's something that I notice right away. These two lines are overlapping one to another. What does that tell me? Well, this tells me that this is an infinite solution system. Why? Because my lines are overlapping, which means they are constantly intersecting. This tells me that they will always intersect, so there's an infinite amount of solutions. If there's an infinite amount of points these two lines share.